Hi, welcome back. In this video, we're going to go over the very first section of Chapter 1, Section 1.1, and the goal is to introduce the idea of physics and what are we exactly going to be doing in this conceptual physics course. All right, so before we go into physics, we're going to see how it fits in the context of science. So we're going to ask the question, what is science? Then we'll look closer at physics in particular. We'll talk also about sustainability. This course is part of the sustainability bundle, and we'll try to see how the two fit together. And finally, we'll talk about the scientific model and scientific attitude. All right, so first of all, what is science? So I'd like to actually pause maybe the video and try to just think about what comes to mind when you think science. And I'm guessing probably you're thinking about different fields or different branches of science. And usually we divide them into what covers the living things and what covers the non-living things. And so life sciences, covering the living things, would be, for example, biology, zoology, botany, depending on what kind of life they study. And then we have the physical sciences, which would be physics, chemistry, geology, astronomy, and you can see that these describe non-living objects. And as you know, we don't actually have to keep them separate. In a lot of modern fields, we actually have them overlap. So there's actually a lot of research done in biophysics, for example, or biochemistry, where we can study the motion of cells in your body, for example, using essentially a physics concept applied to a biological an object. All right, so physics we just saw with physical science. It's also what we call a natural science. And so what are we going to do in this course? And again, if you want, I would pause and just think for yourself, how would you define physics? And you may have already looked through the syllabus and you may have looked at the concept that we're going to cover. But the idea is that we're going to be studying matter, and we'll see that it takes various forms that we'll look into in various chapters throughout the semester. We're going to be talking about solid objects as first, and eventually we'll see what happens when we're dealing with liquids or gases, for example. And then we look at their motion and how they behave. And when we do that, you'll see that we're going to use very precise metrics. We're going to have to, let's say, define, a start time, for example. So your motion is going to start at this time and in this space. And so we'll have to be very careful about how we start our measurements and how we make measurements. And we'll see in the next video how we have to use the correct units when we report those measurements. And so when we describe the behaviors of these objects, we do so using properties such as temperature, energy. You can think of a number of them probably. You can measure the mass of an object, and you can, as we'll see, you can measure its charge, something you may not be as familiar with. But we're going to be looking at a lot of different quantities that are going to allow us to describe them better depending on the context and what's needed. We'll see also how their environment has an effect on them, and that means looking at forces that are acting on them, for example, or how they are going to interact if you put them in contact with a hotter object, and how we'll see that heat is going to be flowing from one object to the other. So lots of things that we're going to cover throughout the semester. But the idea is with everything that we're going to cover, everything that we're going to be talking about, really, there's one big question that we're trying to answer behind all of these different topics that we're covering. And that question is really, how does the universe work? How does the universe behave? And so what's neat about physics is that it's really one of the most fundamental scientific disciplines, because we're really asking those why questions and really looking at, what our world is made of, and how is it that you can see me through the screen, and how is it that the screen works at all, and how is the information getting to you? All of these things are questions that physics can answer, or tries to. All right. So we're also going to be talking about sustainability. As we're dealing with a lot of issues these days, and one is climate change, and global warming, and all of these kind of questions. And it could be that with studying physics, we may actually have some answers, even though it seems like a very different field. So for now, I don't actually want to tell you what sustainability is. I want you to think about what it means, and we'll see that there is a discussion set up in Canvas for you to start exploring the concept and how it's going to work within a physics course. But here I put some questions to give you some idea of the things that we can try to explore throughout this course, and along with the study of the physical concept that we're going to go over throughout the semester. The first question I have here, physics and sustainability, same bottle, that actually fits with what we're going to be talking about next, and how we're going to approach the world, and how we're going to be asking questions when we're talking as scientists or physicists. Because really, the key thing to be able to answer those big questions of how to fight climate change is to really understand the problem. So knowledge is key, and we'll see how we approach knowledge, and how we approach just even asking a question using the scientific method in just a minute. But before we do that, I just want to go over other questions. So one other issue is the impact of overconsumption of life on life as we know it. And so how would that fit in a course like this one? We'll see that there's I posted an article, you'll see, on how Newton's laws of motion actually can be applied to see how life adapts to their habitats being destroyed. We'll talk about collisions and what happens when you have too many satellites up there, and eventually some of them become trash, and you have other trash, and then essentially what would happen if a satellite actually collided with some trash up there. Something else we'll talk about is the concept of rotational motion. And so we can think about things like, what if all of the ice, the glaciers and the iceberg melted? Would it actually have an effect on the rotation of the Earth? And would that change the duration of a day? All right, so things like that we can try to answer. And a big one that usually we think about when we talk about physics and sustainability is the idea of the concept of energy and energy efficiency. And we'll look at different forms of energy, and maybe we can think about different ways that we can harvest energy that are greener and more sustainable. All right. Again, that's something that we'll be talking about throughout the semester. Whenever we get a chance. Also, the final project that you're going to be working on should have a sustainability aspect to it. All right, so the last point here I want to make in this video is how what kind of language we should use and how we're going to approach problems when we're in this physics context or scientific context. And one method is what we call the scientific method. And we'll see that in a lot more details actually when we talk about the final project, because as it turns out, we're going to look at the various steps that need to be taken as you apply the scientific method. And each of those steps is going to essentially be an assignment to work towards that project. And you'll be working on it throughout the semester. So we start with observations. And so, and you don't have to think about it here for in the context of physics, but you know, you can maybe you've been driving to school or to work, you know, every day, and you've noticed something on your route, and or something else that's silly or that's really important to you. And basically, at this point, we're just looking, we're taking in the information, we're collecting that information, and given that information that we have, we see a problem. So we can define a problem, and it can be based on observations that are going to be qualitative or quantitative. So something that you can measure. So you can put it on a scale, or you can put a thermometer on it and it gives you a measurement, or something that is more qualitative. And at this point, so you have a problem, and you could make an educated guess about the answer. And that's what we're going to call our hypothesis. And so you'll be, for your project, making a hypothesis, but don't worry, you'll see we'll have lots of resources. We'll talk about how to do research to figure out that problem, and we'll even have help from the library. And at this point, you have essentially made your educated guess, and the next part would be to predict the outcome of your hypothesis. And so at this point, you can design experiments to test those predictions, and then you see what happens. And you have to be very careful in the conclusion to make sure that you're not actually biased, but you know, you had that educated guess, and maybe you really thought it was going to go one way, and maybe when you actually perform your experiment, you find something else. So we have to be very open and very honest in this approach. So this is very briefly the scientific method, and again, we're going to go into this in a lot more details. That's not always how we make discoveries and how we establish. You'll see, we'll talk in a minute about laws and theories. A lot of the time, it's also trial and error. So you actually meant to do something and something else happened. I'm sure that has happened to you before. You know, when you accidentally discovered something. I know, for example, I one time was trying to make whipped cream, and so I put my whipping cream, and I started getting that going, and then I kind of forgot about it, and it was doing that, and I came back and I had made butter. So I discovered accidentally how to make butter out of cream. So sometimes you don't really have a plan, but you make a discovery anyways, and it's not necessarily following the scientific method. So again, we have to be open to outcomes. And this is all part of what we call the scientific attitude. And in a lot of ways, it's to be really honest, and also we have to kind of stick to the facts. And so what is a fact? All right, so here we define a fact as a close agreement by competent observers making a series of observations of the same phenomenon. Okay, so that means that you take a number of people, and depending on the field, you can have experts on the field, but sometimes depending on what you're observing, it doesn't necessarily have to be the case, but you have all these people who look at the exact same thing and make their independent observations. And then if everybody seems to be observing the same thing, then everybody agrees, and then we can call this a fact. Okay, so the hypothesis we were just talking about, that is not a fact, because remember we said that was an educated guess. So we had this problem and we kind of have an idea of what's going to happen, but we don't know for sure, because we haven't actually experimented. We haven't actually done anything that showed that it would be something that we can just accept as fact. So we have to be very careful not to mix those two things. And an hypothesis is also something that we need to keep testing. So, and first of all, we'll talk about the testability, or what's is something that you can test or not test, or what's a good hypothesis versus not so good hypothesis. Because as it turns out, if you pick something that cannot be proven wrong, then we're kind of stuck in the process, and you can claim that, well, you're not proving it wrong, so you must be right, and that is not a good way to it's not a good scientific attitude. So, but if you test it over and over, and you don't find any contradiction, then your hypothesis may become a law or a principle. All right, and so we always have to keep an open mind, and it could be that eventually, even if you've established, a law or principle, one day someone comes in and actually finds something that contradicts this, and then we need to abandon it, or at least change it. And we'll talk about time in the history of physics where it has happened. And it's happened actually quite often. And so that means we should always keep an open mind. And even in the way that the state of science today, we should always think that, we don't have the full picture. We should keep testing everything. And so when you have a number of hypotheses and you're trying to describe a number of phenomena that are maybe in the same realm, and you have a lot of hypotheses that are essentially well tested, and so you're getting all of this information that you can essentially put in what we call a scientific theory. And we'll go over some examples of those definitely throughout the semester. All right, so we just talked about how there could be hypotheses that would be actually not so great. And before we go into actually figuring out a hypothesis for your project, let's think about what would be a good one and what would be a bad one. So a key thing here is that it has to be testable. Okay, so we need to have a way to prove it wrong. Even if we don't necessarily want to, it needs to be something that can be proven wrong. Otherwise, if you cannot prove it wrong, if it's not testable, then it's not a scientific hypothesis. All right, so we're going to look at a couple of examples. I'll read 2 statements, and then you can pause the video if you want. I want you to stop and think about whether they are testable or not. So the first one states that quarks are the smallest particles of matter. Quarks are something that come into the very last chapter of the semester. So eventually we'll talk about that. Quarks is often more to say. Anyways, the second one is Albert Einstein was the greatest physicist of the 1900s. All right. So think about which one is testable and which one is not, because there's one of each. All right. If you don't want to hear the answer, you can pause and think about it for yourself. All right. So if we look at the first statement, to prove it wrong, all we would have to do is find something that is smaller than the quark. And if we found something smaller than a quark, it would mean that the quark is not the smallest particle of matter. Okay. For the second statement, it's really more a matter of opinion. And so that one is trickier. All right. Okay, so now I want you to think about 2 statements, one which is a scientific hypothesis and another statement that is not. And then you feel free to share in the discussion board, or share with somebody outside of the class also, and test out their understanding and try to maybe teach someone outside of class what a scientific hypothesis is. As it turns out, you don't have to apply this to physics. There are lots of different topics that where you can define a scientific hypothesis or something that would not be one. And try, and when you're looking at news and things like that, try to think, does it seem like something that would fit well in the scientific method, or is it not so much? And we're going to be addressing those questions a lot more when we start talking about research and how to pick good resources and whatnot. So all right, so I will leave you here for now. In the next video, we'll talk about measurements. We'll talk about units and how you should always report any numbers with its units. And we'll talk about different systems of units and what we're going to be using in this course. All right, bye.